Before we understand what a file system is, we need to understand what exactly does a file system keep a track of. Okay. So basically, as we understood yesterday, file system is a way to organize and arrange data on the storage medium, right? So it exactly keeps a metadata or an index or a journal, whatever you may want to call it, okay, as to where exactly a particular file or contents of a file are stored on the storage medium. Okay, that storage medium may be a single hard disk, maybe a single SD card, or the storage medium may be multiple hard disks or multiple solid state drives. Doesn't matter, the concept still remains the same. Okay, so that is what we are going to learn today, and we are also going to see how in our day-to-day lives we use a file system, but we are ignorant of the effects of the file system. Okay, and we are going to learn that today. Somebody jumped off the call. Okay, let them join in back. So I'm going to share my screen. Okay. Are you able to see the screen? See my screen? Okay. So we learned a little bit about hard disks as to what does a hard disk contain internally, but that was more of a physical structure of a hard disk, right? Today we are going to see how that physical structure is broken down into logical structures, and how this logical structure is being used by the file system to keep a track of or keep a journal or index of where exactly data is being stored on the storage medium. Okay, and in between, if you have any questions, please do interrupt, raise your hand and ask. Now, we all know that hard disks are sealed like this, and once we go inside a hard disk, we will see these magnetic platters, right? The magnetic platters are all concentric disk platters coated by an electromagnetic surface on both sides. And then we have this actuator arm. This actuator arm moves so much, okay, across the surface of the platter, and on the tip of the actuator arm there is a needle which can write and read. And as you can see, the actuator arm can move only so much, okay, roughly about 15 degrees. Then inside, on the magnetic platter itself, each I would say circle, each platter is logically divided into something called as tracks. Okay, each platter is logically divided into something called as tracks. That means there will be tracks on the top surface and there will be tracks at the bottom surface also. Okay, what are these tracks? These tracks are nothing but concentric circles. Right from the outer edge of the magnetic platter, they will come in like this, just like the tracks on a gramophone record. Exactly the same analogy. Now, each of these tracks are further divided into logical sections called as sectors. Each track is further divided into logical sections called as sectors. Okay, so as I said earlier, each surface of the magnetic platter, both on the top and the bottom, are divided into logical units called as tracks. They are nothing but concentric circles from the outside edge to the inside edge of the platter. And furthermore, each track is further divided into more finer sections called as sectors. Okay, And what the magnetic head or the on the actuator arm does, it places itself on a track, and while the platter is moving, it knows it is on which track, and exactly at that position when a sector comes, it knows what to write on that sector or what to read from that sector. Whereas this kind of mechanism is not there in SSDs, right? We understood that SSDs have absolutely no moving parts. It's all electronic and electrical components, but they are more expensive and hard disks are less expensive. That is why we see a combination of both of them in today's world. Okay. Now we go into a little bit more detail of understanding how the logical sections of a hard disk drive are used to address uh, the various sections, you know, which are there inside the hard disk, and how those various sections can be used to create a logical addressing scheme. Okay, and we will see how we are going to make use of that. So we are already understood this, that what is a platter. Platter is nothing but the magnetic material, and then we have the spindle in the middle. The spindle is the one which allows the hard disk platter to spin. Okay, and it'll always spin in one direction only, it will not spin in multiple directions. And these are the tracks. Okay, these are nothing but concentric circles from the outer edge of the platter all the way till the inner edge. Okay, and these tracks are there both at the top surface as well as at the bottom surface. And then if you take concentric or same tracks across platters, okay, that's called a cylinder. Okay, this is very important, please understand. So let's say that the top platter has got 10 tracks. The outside track is track 1, then track 2, then track 3, so on and so forth. So track 1 on platter 1, track 1 on platter 2, track 1 on platter 3, track 1 on platter 4. So the same track on all the platters put together combined is called one cylinder. Okay. Similarly, track 3 on platter 1, platter 2, platter 3, platter 4 is called one cylinder. Okay. Obviously, right? If you put multiple rings on top of each other, what it will form? It will form a cylinder. So each track has got a logical address, each cylinder has got a logical address, and furthermore, the tracks and cylinders are further divided into something called as sectors. Okay, so there are three logical components inside a hard disk drive: a track, a cylinder, and a sector. Okay, and what the actuator arm does is it identifies which cylinder, which track, and which sector to read or write information from. Okay, so little more detail. Okay, so this is on the platter, this is a track. And yes, Anand, yes, Anand, you have a question, go ahead.
The spindle use is just to hold the platters together. That's it, right?
That's correct. That's correct. So spindle has no logical identification. It is
Okay.
just a mechanical device. It is connected to an electric motor. Okay. And
Okay.
that motor is designed to spin at a certain speed only, no variable speeds. Okay. And
Okay.
that is why if you go to the disk manufacturer, spec sheet, right, which you had downloaded as a exercise of class 1, okay, you would have seen a particular metric called RPM, rotations per minute or revolutions per minute, right? That
Yes.
RPM of a hard disk is nothing but the measure of how fast that spindle can spin the platters. So
Okay.
we have hard disks of various RPMs. So we have hard disks with 7.2K RPM. 7.2K means 7,200 revolutions per minute. Okay. Then we have 10K RPM, 10,000 revolutions per minute. Then we have 15K RPM, 15,000 revolutions per minute. But that's the limit, okay? In the world
Okay.
today, we do not have any hard disk which can spin faster than 15K RPM, okay? So
Okay.
once you go and start reading the spec sheets again, wherever you see hard disk, okay, or the kind of hard disks that can be put in a server or that can be put in a storage system, you will always see a RPM measurement or an RPM metric assigned to a hard disk. And that RPM metric is the measure of how fast the spindle can rotate this magnetic platters. Okay?
Okay.
Okay. Now, I have a question for you all. Why, even after so many decades of, industry evolution and technology advancements, the top speed of a magnetic platter or the spindle is only 15K RPM and not more than that? So you all would have downloaded these spec sheets, right? Okay, various spec sheets over the last few days, right? Just pick any one of them. Go to the hard disk sections, okay? And see if you can find any hard disk drive which has got RPM more than 15K. I'm pretty sure you will not find any. So my question to you is why? Why there are no hard disks more than 15K RPM speed?
I guess because of the speed, if the speed is more, it will generate more heat.
More heat?
Yeah,
Mm, you're partially right, but not completely. But good answer, good thinking. Anybody else? Okay, let me explain to you. And just stop sharing for a minute. See, in our childhood days, when we were all on bicycles, right? Even till today, many of us ride bicycles. So you would have experienced this. Whenever you are, cycling very fast, okay, the wheels start to wobble like this, right? Even in your bikes, okay, I'm sure many of you are bike fanatics. The moment you go beyond a certain speed, right? Like beyond 80, beyond 100, okay? Your wheels start to wobble like this, okay? And there is no mechanism to control that wobble, isn't it? Only in a car you can do it, but that too, still it will wobble. Okay, that's why tire alignment, all this is done, right? To reduce that wobble whenever you're in high speeds. Why? This is the law of physics. This is the law of nature. Whenever you have huge centrifugal and centripetal forces, okay, on a particular spinning object, there will definitely be a wobble, okay? And that wobble is something which is uncontrollable, okay? And that can lead to catastrophic effects. And because of this reason, if you take the hard disk RPM beyond 15K RPM, the wobble is so much that it will touch the actuator arm. We all saw that hard disk platters are spinning inside the small gap in an actuator arm, and the needle at the tip of the actuator arm is responsible for reading and writing on the hard disk platter, right? So if there is wobble, right, if the hard disk is moving and wobbling like this, there is very good chance that it is going to touch these actuator arms and there is going to be physical damage on the hard disk platter, right? And if there is physical damage, those tracks, those sectors, those cylinders become unreadable. So what will happen? Even though you say that your hard disk is like a 10 terabyte, 20 terabyte, 30 terabyte, and let's say it is 30K RPM, okay, you will not get that amount of storage space on it because of physical damage. A lot of tracks and sectors and cylinders will get damaged, and you will not be able to read or write on them, right? So this is the reason why the industry has capped the upper limit of the speed of hard disks to be at 15K RPM, okay, not beyond that. And most prevalent hard disk are of two types: 7.2K RPM, which are called as SATA hard drives. I will tell you why. And then 10K RPM SAS. We understood what was SATA and SAS. They are protocols of interfaces which are connecting the hard disks to the storage system or to the server. So, uh, 7.2K RPM SATA, where high density drives are there, 30 TB, 60 TB, 70 TB, so on and so forth. And we have 10K RPM SAS drives, which are in the measure of 300 GB, 450, 600, 900, 1.1 terabyte. These are the ranges of 10K RPM drives. Prakash, does the data stored in the Of course, yes. That's the idea, right? That is exactly what we are going to see now, how data is getting written on these platters. Okay, so just observe this animation carefully. So we understood that a platter is logically divided into tracks, tracks further divided into sectors. Concentric tracks are called as cylinders, right? And each track, each sector, and each cylinder has got a unique address, and that is what we will logically refer to while identifying where exactly we need to write on that particular platter. So these are the various tracks inside a hard disk drive. Okay. And as I said, these are all divided into sectors like this. Okay. So this again is very important. Okay. In the last line of the description on this video, you see that the data size of a sector is always a power of 2. Power of 2 means what? 2 to the power something. Okay. Like 2 square is 4, 2 cube is 8, 2 to the power 4 is 16, so on and so forth, right? So it will always 2 to the power something. Why 2 to the power? Because of binary, because it's ultimately zeros and ones, right? So to understand how much data a particular sector can store, okay, that is in measured in this, which is called a sector size. It's in measured in 2 to the power something, okay. And the higher the sector, the sector size, the greater is the density of that particular hard disk drive, which means that is the more amount of data can be stored on that particular hard drive. Okay. Typically, we see hard disk drives of 512 bytes. Okay, 512 bytes is the typical sector size, okay, of a hard disk platter. Moving forward, and multiple sectors together form something called as a cluster. Okay, multiple sectors together is called a cluster. And when the actuator arm comes in through that interface, that SCSI interface, okay, an address is being sent to that actuator arm. Okay, and the small motor which is controlling the actuator arm, it will tell the actuator arm, okay, do a read operation from so and so track, so and so sector, or so and so cylinder. Okay. Similarly, it will say go and read from so and so track, so and so sector. Okay. So this, which track, which sector to read an information from or write an information to, who is telling the hard disk? Who is giving this instruction to the hard disk saying that please go and read from so and so cylinder track or sector, or go and write to so and so cylinder track or sector? Any guesses?
Protocols,
Which protocol?
according to the RPM, sir, data
Okay,
organized.
okay. Partially right. Partially right. Any other answers? Any other answers? So this is a good animation. The hard disk is continuously spinning, right? And the actuator arm can only move so much, roughly about whatever is the distance from the innermost track to the outermost track. Okay, only that degree of movement is there with the actuator arm. And at the tip of the actuator arm is where the read and write head is there. And when the actuator arm is moving, all the arms are moving, right? Together. All the arms are moving together. So whenever it is reading or writing, it is reading and writing to all the platters together. Okay, and that is where the efficiency of read and write increases. If you're reading only one platter at a given point in time, it is not going to be very effective. Okay, so the best performance you will get only when you're simultaneously reading from multiple tracks and sectors together. Okay, so my question remains to you all: who is, which component is sending information to this actuator arm to tell which cylinder, which track, which sector to read from, or which cylinder, which track, which sector to write the data into? Hmm? Any guesses? The answer is there on this slide. It's the file system. Okay, who knows where what is written? Yesterday we understood, right? When we go earlier days when there were no computers, how bank records of our accounts were being stored in the form of ledgers. Each ledger is like a file, right? And only the person or the people who are maintaining the index of all the ledgers, they will know exactly where which ledger is placed, which file is placed, and they will know where to read from and which file to write into, right? So that's exactly a file system, right? And it is the file system which gives the instructions to the hard disks underneath it to tell the actuator arm which track, which cylinder to read or write from. Okay, so before we get into understanding this file system concept, okay, let us do our practical exercise. Okay, and it's going to be exciting, but a word of caution. Okay, don't click anywhere while I'm telling you. Don't click anywhere, because a wrong click can help in completely deleting the data from your laptop hard drive. Okay, and it can result in permanent loss of data, making your laptop unusable. Okay, extremely carefully you do this exercise. Okay, so I am in the chat. Can all of you Oh, okay, there was another question from Prakash. Any count of platters, do number of platters have any role in efficiency and data speed? Like more platters, more efficient, less platters, less efficient. Yes, 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 Prakash, absolutely. The so initially, when hard disk came into the market, the number of tracks uh, on a platter were less. Okay, but the number of platters also. First, hard disk used to come with only one platter, then multiple platters started coming in. But as you know, there is a physical size and dimension restriction. Okay, and you have to adhere to some industry standards. So you cannot have, as many number of platters as you want in a hard disk. Okay, so there are limited, as we have been discussing from day one. It's like 4 to 5 only. The efficiency in terms of how much more can you store does not depend directly on the number of platters, but the number of tracks, okay, that have been carved into the hard disk platter, the carved into the surface of the hard disk platter. That matters. Okay, number of tracks. And what also matters is the density of the sector size. We saw that it's a power of 2, right? 2 to the power something. Typically, it is 512. But in denser hard disk, that sector size increases. So the hard disk is allowing you to write more into a given sector. That's how the density increases, okay, of the hard disk. And these are certain important factors using which the efficiency of a hard disk varies. Okay, and that is the reason why there are today so many different, hard disk models across the globe, across manufacturers. Some will be better in speed, some will be better in storage capacity, some will be better in efficiency, less number of errors, okay, those kind of things. Okay, but the top 10 manufacturers which you have got from, ChatGPT or the web, they are the most prevalent. Samsung, Hitachi, Western Digital, okay, Solidigm, that is in SSDs. Okay, these are the ones you will see mostly in most storage systems and servers. Okay, though they come rebranded from the server manufacturer or the storage manufacturer, but ultimately these storage and server manufacturers outsource the hard disk manufacturing to this hard disk companies. Okay, Seagate, okay, all of these people. All right, and these guys do that only one thing: they manufacture hard disks. That's all. All right, all right. So in the does that answer your question, Anand, Prakash? Anand, you have one more question? Please go
Yes,
ahead.
sir. I have also dropped a question in the chat box. That do you have any particular count for the number of tracks on the each letter, sir?
Yes, yes. There is a count, but those counts are not published. Okay. They are not published. It's a well kept secret within the hard disk manufacturer. Okay. But what they publish in the spec sheet is what we see. Okay.
Okay, sir.
Yeah. Yeah. All right. So, all of you in the chat, can you please write which model of laptop are you currently using? And what is the version of Windows operating system that you're using? All of you are using Windows, right? Anybody is using a Mac here? A non-Windows laptop? No? Okay, cool. HP Omen Windows 11. Prakash. Okay. Hari, all of you please type. Shivani, Renu, Jagdish, Gopi, Anand, and Bhanu. Come on, come on. Lenovo IdeaPad S145 Windows 10. Okay. Gopi HP Pavilion 15 i5 Gen. But what is Gopi? What is the Windows version? Windows operating system version you have to mention. Anand, Lenovo i5 Windows 10. Okay. Renu HP Pavilion Windows 10. Cool. Gopi is Windows 11. Okay. Okay. Bhanu, what's yours? Bhanu? Bhanu, are you there? Can't hear you. Lenovo Legion. Anand is Windows 11. Bhanu is also Windows 11. Okay. So, Bhanu, can you please share your screen? And while Bhanu is doing this, okay, uh, all of you also can practice this, okay? And you will really understand what exactly is a file system. Then we'll see what a file system is, okay? And then we will relate to it in our YouTube video and in our course content, okay? Yeah. Bhanu, can you go to Windows Explorer first? Yes. Now, on your Windows Explorer, on the left-hand side, you see this PC. Okay, can you expand the left-hand side column? Can you expand it a little? That divider. Can you expand that divider? Yes. So you see under this PC, you will see the various partitions, not hard disks. Okay, these are logical partitions. We will see what a partition is later. Okay, we will see these naming convention in the form of drive letters. Okay, alphabets C colon D colon E colon. Okay, these are each individual partitions. Okay, now Banu, can you right click on D and go to properties? Okay, great. Uh, can you bring it to the center? Yes, yes. Okay. Now, all of you, you can right click any one of those drive letters in your laptop, okay? And you go to properties. And in the chat box, can you please type? Banu, you don't need to type. What do you see under this second section, under the name, right below the name, right? You will see local drive or local disk written, and under that something is written next to file system. Okay. In this case, Manu's laptop, it is written as NTFS. Yes, Prakash, NTFS. Okay. NTFS. Good. Gopi. Hari, NTFS. Good. And we please don't click on anything unless I tell you and show you. Okay. Because it may delete a lot of data. Yes. So quickly go to Wikipedia and tell me what does NTFS stand for? Yes, all Windows laptops, all Windows servers will have this only, NTFS. Okay. So Bhanu, can you open a new tab and go to Wikipedia and type NTFS so that everybody can see on the screen? Yes, Anand, correct. It's new technology file system. Correct. NTFS wiki. That's right. Okay. So it's called new technology file system. See, when it was invented in the year 1990, by whom? Microsoft. Okay. It was invented in 1990 but released in the market in 1993. Okay. And it first got shipped with a version of Windows called Windows 3.1. That is what we used to use. Okay. When we were very small, right? Okay. But if you see, there were other file systems also. It clearly states in the second paragraph, it was developed to overcome scalability, security, and other limitations with FAT. Okay. You're not using laptop today. I've joined through mobile. No problem, Shivani. No problem. As you know, this section, these classes are recorded. Okay. You practice it once you have a laptop with you. Okay. No issues. I'll be uploading the recording quickly today. Yeah. So there was an earlier file system released by Microsoft called FAT. Okay. FAT stands for File Allocation Table. So that was the primitive way of designing a file system, file allocation table. Okay, FAT. Now, what is the function of this NTFS or FAT? As I said earlier, nothing much. Okay, though I'm trying to oversimplify it, but that is, you will see the foundation of any storage, internal, external, okay, your SSDs, anything. Okay, that is the foundation of your storage. See, same thing we can see in our mobile phones also, that we will see later, that there is a file system in our mobile phones also. Okay. So how to understand what exactly is a file system, I'll tell you on your mobile phone. But first, let us focus on this. Okay. So it says that it's a proprietary journaling file system. What does the word journaling mean? Journaling means keeping a journal, keeping a track of what is being written where, what is being read from, and from which physical space. Now come down, Bhanu, on this wiki page. Come down, further down. Yeah. Wait. On the right hand side, on the right hand side, you see the specifications of this file system, right? Go a little further up, little further. Yes. Okay. So, do you see certain things called max volume size, max file size, max number of files, so on and so forth? Okay. So, a file system which has got this very critical job of keeping a track of where which file is being stored on that magnetic platters. Okay. These file systems also have limitations because they are ultimately nothing but a specialized specific purpose software. Okay. Which is running somewhere. And these software definitely have certain limitations. Okay. These limitations are mentioned here, and any vendor, when they're releasing a file system, they have to publish the limitations also. Now if you see here, max volume size, what does this max volume size mean? It means that What can be the maximum capacity that this file system or this version of the file system can address? Okay. As you can see, it is clearly mentioned. The minimum size is 64 KB, kilobytes, but the maximum size is 256 terabytes. Okay. And that max size also depends upon which version of the operating system are you using on your laptop or your server. Okay. And it clearly says, see, if it is Windows 10 version so and so, if it is Windows Server 2016 or so and so. Okay. If it is Windows Server 2019 or later, then the same NTFS file system can go up to 8 petabytes. Can you see the huge amount of difference? Where is 256 terabytes and where is 8 petabytes? Huge improvement. Okay. Improvement, multifold improvement. Okay. So what does this tell you about a file system? Who owns it? Or what software when you install, you get the file system also? Or who controls the file system? Very simple. It's there on the page itself. And all of you had mentioned what is the version of Windows you're running on your
OS.
laptop. OS, yes, operating system. Correct. Correct, Hari. Okay. So it is the operating system which is, or the operating system vendor which is developing the file system, and they are the ones who own it, who control it. Okay. And depending upon which version of operating system are you installing on your laptop, your phone, your server, you will get the choice of file systems compatible with that operating system. Okay. And that compatibility is mentioned in the specification sheet of that operating system. Okay. That these are the types of file systems it supports. These are the maximum limits. Okay. This is what you can do, everything of that sort. Understood? Any questions on whatever we have learned so far about a file system? We'll get deeper. Okay. No problem. Then you also see max file size. What is the maximum size of a single file that it can store? Okay. As you can see, it's really very high. Okay. 16 terabytes to 64 kilobytes to 16 terabytes. So a single file can be 16 terabytes in size. And if it is a newer operating system, newer version, that size keeps on increasing. The minimum remains the same, 64 KB, but the max keeps increasing, right? You are getting 256 terabyte also. Manu, can you keep highlighting these metrics as I'm telling you under the max file size so that everybody can look at it on the right hand side? On the right hand side, yes. The second line, yes, that part, correct, correct. And as you see, if you go to the Windows Server 2019 or Windows 10 version, you all are using Windows 11, so that's a higher version. So a single file can be of 8 petabytes also. Okay, so huge improvement. Then the next line, the max number of files, there is a limit on that also. Okay. So in this case, it is close to 4 billion. So you can store 4 billion files in a single file system. Okay. Uh, Come down, Banu. Can you please scroll down, Banu? Yeah. So then there are many other attributes to a file system. We will understand that a little later. Okay. Any questions of what we have learned so far? No, right? Okay. Manu, can we go back to Windows Explorer, Manu? Can we go to the Windows Explorer? Yes. So right click and go to properties again. Right click on D drive and go to properties. Yes. Now we see that the file system is NTFS. So now we understand, okay, how is this NTFS coming? It is coming because you're using a Windows laptop. If you're using a Mac like me, then it will be different because Mac OS is different from Windows OS. So a different file system is being used. Okay, I will show you that also. And now, Bhanu, can you click on details? Can you click on details button? Bottom there. Yes. Okay. When you click on details, it is showing you lot many more details about what kind of data is actually getting stored in your hard disk. How much is the total capacity? 484 GB. How much of it is being used? 272 GB. How much is free? 212 GB. Okay. Which kind of file is occupying how much space? All that is visible here. Okay, you can see. So, who is keeping track of all this? That file system, NTFS. Okay, NTFS is keeping a track of all this. Right? Can you scroll down, Bhanu? Right. Now, can you close this? Okay. Now, can you go to that section tab called hardware? You see on the top, there are 8 tabs. Okay. General, tools, sharing, security, previous versions, quota, and customize. Okay. So when you go and right click on any drive letter, apart from CD/DVD-ROM, okay, any hard disk, you go, you will see this hardware tab also. Okay. Now in this hardware tab, what Bhanu is showing, okay, Anand says I'm having REFS type of file system to one of my drives. We'll come there. We'll come there. What is REFS? We'll come there. Okay. Let us first finish the NTFS because this is the most common file system that you're going to see across Windows servers in customer environments also. So let us understand this properly and then we'll get into the other kinds of file systems. Okay. All right. Now, can anybody, by seeing what is visible on the screen here, who is the manufacturer of the hard disk drive that is in Banu's laptop?
I'm sorry.
Samsung, correct. And does Banu have a single hard disk or he has multiple hard disks?
Multiple, sir. Two.
Two, right? So the first one is Samsung. How about the second one? Banu, can you click on the second drive in your laptop? Yeah, how about this?
It mentions manufacturer standard rectified.
So all you have to do is you in that name you have ST1000LM049 hyphen 2GH172, whatever is written. You just put that in Google. Okay, you will understand who is the manufacturer. Can anybody do that and put the answer in the chat?
Seagate.
Seagate, correct. So that ST, right? Seagate Technologies. Okay. ST is the code name or abbreviation for Seagate. So Bhanu is having two hard disks in his laptop. One is manufactured by Samsung and one is manufactured by Seagate. So remember what we spoke about protocols. Okay, because both Samsung and Seagate are adhering to the same industry standards and making their disk drives compatible to the same protocols in the same laptop using the same operating system using the same file system, you can still have hard disks from multiple manufacturers working together. Okay, does this make sense? Now you are able to relate. Oh, which means in a storage system also, all those hundreds of hard disks, all those hundreds of SSDs that I have, all of them need not be from the same manufacturer, not required. As long as they are compatible from a hardware perspective to be put into those respective slots inside the disk shelf, inside the controller chassis, okay, and that interface is following a standard protocol, okay, like SAS or SATA or SCSI, okay, it's fine. The manufacturer doesn't matter, okay, it should still work. But in enterprise class storage systems, it may not work because the storage manufacturers do some tweaking after they receive the hard disk in their factory. So what is that will come later. Then under that hard disk name, you see certain parameters of the hard disk, right? It talks about who is the manufacturer. Here it is unable to recognize. Okay, maybe it's a old hard drive. Okay, and it also says what is the location of the hard disk. Now, what is this here? What is location of a hard disk? In one laptop, you have one hard disk only, no? But in Bhanu's case, it is a little different. He has two hard disks. So, what is his location? And it has given certain numbers also to this location. They are saying bus number, target ID, and LUN. There is some number attached to that LUN. Okay. Now, what's all this? Can anybody take a guess? Click on that Samsung hard disk, Bhanu, on the top. You see the location has changed. Okay. But the bus number, target ID, and LUN number still are the same. Now, what is this? This is really confusing. Hai na? Just the location has changed, but the bus number, target ID, and LUN ID are still the same. Okay. What is happening here? Let me explain. If you go back to our yesterday's class, where we were talking about how we can connect hundreds of hard disks using something called as a daisy chaining or cabling from the controller to the disk shelf, from one disk shelf to another disk shelf, so on and so forth. Okay. So that particular port on the controller, okay, where we saw that it was a SAS port, okay, and using that SAS port you are connecting to the first disk shelf and then one more SAS port to the last disk shelf to end the loop, okay, that loop number, okay, is called as the location or bus number, okay, which means that cable or that port to which the cable is connected and through which the controller is connecting physically to the hard disks, okay, that is called the location identifier or the bus number, okay. If it is the first port, it is bus 0, okay. If it is the second port, it is bus 1. If it is the third port, it is bus 2, so on and so forth, okay. So the cable using which the SAS loop or the counting starts, okay. So that gives the bus number, okay. Now, what is the second parameter? Okay, once a bus is connected to a disk shelf, but in that disk shelf there are so many hard disks, no, in a storage system. It's not just one hard disk, all right. So the leftmost disk will have location 0 and from there it starts counting location 0, location 1, location 2, location 3, location 4, so on and so forth. So when you pick any hard disk from inside the storage system, the way the controller will identify that particular hard disk is by using its bus number and location number. And that's exactly what we are seeing here today, right? The way the operating system is able to uniquely identify which hard disk is what by using a combination of these two numbers. One is the bus number and the second one is the location number. Okay. So using a combination of these two, you can identify which disk drive are we exactly talking about. Okay. So that is why you see, even though the bus number of both the hard disk in Bhanu's laptop is the same, the location number is not the same. Okay. The location is different. And that's how the Windows operating system on Banu's laptop is able to identify, okay, in location 0, I have a Seagate hard disk, and this is its serial number, this is its characteristic, these are its properties. And on location 8, in this case, okay, it is using a Samsung hard disk and it is able to identify that also. Okay, is this clear? Any questions around this? How you can uniquely identify a single hard disk in that hundreds of hard disks by simply using two terms. Yes, thanks Anand for your acknowledgement. Bus number, location number. Very simple. Okay. Now, Manu, can you click on that properties button on that particular hard disk? Yes. And you see the same thing. It says that it is Samsung and all. Go to volumes tab on the top. Yes. And click on the button populate there. Yeah. Go to volumes and click on populate. Yes. So do you see something here? It exactly is able to identify that inside that hard disk what you have done. Okay. The operating system is able to identify, okay, these are the physical characteristics of the hard disk. But apart from the physical characteristics, what are the logical components that have been carved out of that particular hard disk? Okay, so it is saying that this hard disk is actually an SSD. We can see that, right? It is there in the name also. Okay, it's a solid state drive. And this is a classic example of a combination of solid state drive and hard disk drive in the same machine. So, Banu, can you go to the second one and see its properties? The Seagate drive, go to its properties. Yeah, go to volumes and click on populate. Yeah. So this is not an SSD. Okay. This is a normal spinning hard drive. Okay. So the Samsung hard disk in Bhanu's laptop is SSD and the spinning hard drive is from Seagate. Okay. Two different types of hard disks in the same machine. Okay. And still working fine. All right. No problem. Now let us see the characteristics of this Seagate spinning hard disk. Okay. It is able to identify what are the partitions inside. So, which means this entire hard disk has been logically partitioned into two. Okay. What is this logical partitioning? The same way how we live in apartments, right? It's a one whole big building, but each flat is like a partition. We own a portion of that entire building and that our portion is our own flat, right? So similarly, in that entire physical drive, you can logically cut it into various segments and that each segment is called a partition. Okay. And here in Banu's laptop, there are two partitions that have been created out of this single hard disk, right? One is called E drive, one is called D drive. Okay. And you are able to clearly see what is the size of each partition also. We are also seeing that it is online. It is mentioned as disk 0 and there is something else called a partition table, GPT. Okay, that is written on this. So what is a partition table? We'll understand later. Okay, but you see a lot of details are coming out now. And these same things, same concepts, okay, what we are learning now at the laptop level, we will later take it to the server level and then to a storage level. Okay, so we'll gradually increase our scale of understanding, okay, on how storage systems work. All right, let's close this now. Manu, thank you so much. Thank you so much. Okay, some words of caution. Wait, Manu, some words of caution. Can you please share your screen again? Sorry, because I told you that certain actions will delete the data, right? So what are those actions? Let me just tell you so that you don't do this. Right click again and go to properties of any of those disk drives. Okay, so in this first page of any properties of a disk drive, you see in the bottom there are two checkboxes. Okay, there are two checkboxes. First checkbox talks says compress this drive to save disk space. And there is one more checkbox which says allow files on this drive to have contents indexed in addition to file properties. Okay. Now let me explain what these two things are. The first one, it talks about itself, right? It allows you to compress the contents using certain compression algorithm. Okay. Generally, it uses an algorithm called LZ algorithm or GZ algorithm. LZ or GZ. Okay. Either one of these. And any compression algorithm, what it does is it's just simply removes zeros from the content. Okay. And just keeps a track of where that zero was. That's it. So that the amount of physical space occupied on that particular hard disk comes down. Okay. That's simply what a zipping algorithm or compression algorithm does. But it has a downside to it. The advantage of doing compression is getting more space, but the disadvantage is it makes your hard disk run slower because whatever was the original layout or format of writing these files and whatever the file system would have kept track of, okay, this file is here, this file is there, so on and so forth. Once you say compress, it is making some change at the physical layer, right? So it is removing zeros, it is, condensing the entire content into lesser number of tracks and cylinders on the hard disk platter so that you can write more data. But what is happening is that journal or that index that is also getting modified. Okay. And now the file system takes more time to search where exactly the content is, and hence it becomes slower. Okay. So remember this one thing in IT world. If you're getting an advantage, there will always be a hidden disadvantage also. Okay. So just because on the screen you're seeing only the advantage part of it doesn't mean that there is no disadvantage to it at all. Okay. Don't be in that thought process. No, there will always be a hidden disadvantage. But smartly, these manufacturers, these software guys, they don't want to talk about or mention the disadvantage here. They will mention it somewhere in a document and they expect the user to read through it. Okay. And we don't even read our life insurance document. What we will read these things? Okay. Nobody reads it. Okay. So people think that, oh, by doing this, I'll get more space on my hard disk. Yes, you will, but your hard disk will become slower. Okay, that part they don't write here. All right. So this is what will happen if you check on this box. Okay, so be very careful. The second box, it's good if it is already checked. Uh, this is like creating another kind of an index. Okay, see, this NTFS file system was developed in 1990, which means almost 25-30 years back. Okay, or probably more. I'm losing my calculations. Okay, maybe 30-35 years back, right? Now, whatever mechanism they had developed at that time, do you think it will be applicable even after 30 years, after so many technology advancements? No. So, what they have done is in Windows, apart from the journaling mechanism of NTFS file system, which was developed way back, they introduced another mechanism in the operating system called indexing. Okay, so apart from the file system journal that the file system maintains to keep track of where which file has gone, okay, it will keep a separate index somewhere else. Okay, it'll keep referring to the index whenever you're doing any searching. Okay, so and to allow that search to happen quickly, okay, this indexing is used. All right, so these are the two options here. All right, similar mechanisms are available in servers and storage systems also, and we will learn about it when the time comes. All right, so but just giving you an idea. Bhanu, can you go to the next tab called as tools? Yes. So in this tools, you will see two sections here. Okay. One is called as error checking and the second one is called as optimize and defragment. Okay. Now, uh, clicking any of these will not you will not lose data, but these should be done carefully. Okay. Unless you understand what is happening in the backend, uh, it is not advisable to run these two tools. Okay. Now to understand what is happening in the backend, let me share my screen and show you how a file system works. Manu, can you please stop sharing? Thank you. Okay. So here we are seeing a video on how a file system works. Okay. So we have, let us say, this image called TIFF. Now this image is actually stored on your laptop or desktop as a file called, let's say, image1.tiff, which is an image format, right? And a user is coming and he is storing that file onto your hard disk through a file system, right? So these are the key abstractions. Now, what is an abstraction? An abstraction is a logical extrapolation of something that is physical. Okay, so physically it's on a track, it's on a sector, it's on that magnetic platter. Okay, but when you are looking at it, when you are looking at those zeros and ones, you are seeing a file. You are identifying that file as a file name, but the file system identifies it separately in the backend in the form of those tracks, sectors, and all. Okay, and there is a certain hierarchy that is maintained, right? Because always we as humans try to organize our entire data or work or life into logical segments, right? uh, like this, like a hierarchy. So we want to have a larger level hierarchy, and then under that we want to subcategorize all our data, right? So similarly, a file system emulates human thinking, and it allows you to create subdirectories, and under the subdirectories it allows you to create files. And all this structure, all this hierarchy structure is also maintained by the file system. Okay, which means a file system, whenever you are accessing any particular file through a file system, the file system knows the complete path of it. Okay, what is the top level folder, what is the sub level folder, what is the sub level folder in under which that particular file is stored. And this entire path is called as a file path. Okay, uh, in Windows we see it like C drive colon subfolder name slash your file name or something. In Unix based like Mac, you will see it as slash, that is the root. Okay, in Windows the root is the drive letter, the C drive, C colon D colon E colon, whatever you saw see in your laptop, that's the root of the file system. And under that are your subfolders in which the various files and data are stored. And the file system is the one which completely keeps track of all of these. Okay, understood? Any questions here? Okay. Now, let us understand what exactly happens in a file allocation table, right? A file allocation table is the one which keep tracks of what is being written where. It could be on a USB drive, it could be on a hard drive, okay? It could be on any storage media, doesn't matter. Once you do something called as formatting, okay, what gets done is a file system gets written onto the storage medium, and this is what gets happened in the backend. It creates something called as a file allocation table, and in the file allocation table it understands that okay, if you're referring to a particular file, that file is stored in which blocks, or it is, you remember we had something called as sectors, okay, on a track. So consider each block here to be a sector, okay? So even if you are writing a single file or multiple files, all those are, written in sectors on the platter, right? So each sector you can refer to as a block as of now, and it will also understand in the file allocation table which blocks are free and in which blocks data is already written and what data is written and where is the next block, okay? Where is the next block? So for example, block 1 here is here, and if you go to where should I go next to read the next section of the file, it says -1. -1 means go to the previous block. Then from there you go to 2, it reads the one there, and then where should it go next? It should go to block 6. So it will go to block 6, there it will read. Then after that it will say it will go to block 3. So like this, it's a continuous chain, right? Why it has to maintain like this? If you remember our earlier video, the hard disk is continuously spinning and the actuator arm can move only so much. So it cannot write the single file on the same track and in consecutive sectors. It doesn't happen like that. The single file is actually stored in multiple tracks in multiple sectors across the hard disk platters. And that is the reason why this kind of a file allocation table is required to understand, okay, if a user is requesting for a file or a data, okay, where should it go to read the first chunk or the first block or the first sector, then where should it go next to read it, okay, and so on. It finishes the complete, reading of all the blocks from all the sectors. Then it puts together all of this in the memory, okay, and once that entire file is there in the memory, it will open it for you. So this is the mechanism that happens when you actually double click on a file to open it, let us say in a Word or a PowerPoint, or you want to see a video. This is exactly what happens in the file system and in the physical, hard disk. It goes and checks where this file was stored on the hard disk platter, goes and reads all of them into your RAM, puts them together in the RAM, and then it allows you to painting. And see, this is what is there in the directory table format in a Unix kind of a system like Mac. So you'll have the file name, you'll have the starting block, and then you'll have the metadata. That metadata will store, okay, where it go needs to go next. So instead of fat in Unix systems, you'll have something called as inode structure. So we'll see what an inode structure is later. But essentially, this is what it is, right? Now, is this getting clear for all of you? What actually happens inside the file system and on the hard disk when you're actually reading and writing a file? Okay. Any questions? Okay, cool. Last thing I wanted to show you about is journaling, okay, which is this. All right. So journaling is an advanced mechanism of understanding the uh, physical to logical mapping of where data is stored on a physical hard drive. Okay. And how the memory is used to effectively journal the data that is being written or read from a hard disk. Okay. So we all understand what is the function of a CPU. We all understand what is a cache. It's a volatile memory. Then today we understood what is a bus. A bus is nothing but the physical connectivity, okay, between the hard disk drive and the server through which all the read and write happens. And the same bus we will have the RAM or the main memory also, right? So what happens is whatever operations are happening on the disk in terms of read and write operations, all of them are being maintained in the memory and in a separate area on the file system. Okay. And that is called as a journal. Okay. Just like how historians used to journal every activity in history, right? So whenever a king used to go to a war, you will see someone who is making notes, right? And that he is actually keeping a journal, right? So this is the same concept. Whatever read and write operations are happening to the hard disk at the physical layer, okay, all those operations are being captured through the memory onto a separate place, and that place is called as the journal. Okay. And the journal has all the information as to which track, which sector that file is or that portion of the file is being written on, and where to go next. Okay. And this you can also call it like an index. Okay. So this is what is happening internally, right? See, there are a lot more details. Okay. I do not want you to bother you with all those details right now, but I wanted to give you a perspective of what it takes to actually read and write data into a storage system. And this, once we understand that, it becomes easier for us to understand what is happening when we are talking about SAN and NAS. So this is where we were yesterday, right? So we were talking about SAN and NAS, and what was the primary difference between a SAN and a NAS? Who owns the file system? In your laptop, who is owning the file system? The operating system is owning the file system, right? So in a SAN, who is owning the file system? The operating system running on this host or server, that is owning the file system, not the storage. Okay. So who is having the FAT, the file allocation table, or the journaling? So who knows, okay, which data is written to which hard disk on which bus? Okay. That this server knows. The storage system doesn't know. Okay. The storage system knows that, okay, if this server is requesting some data to me, where should I go and fetch it from? That's all. It doesn't even know which file system is written onto that particular storage partition. Okay. It has no clue, no idea. Okay. So there is 100% dependency on this server. Without these servers, in the front, these storage systems will not work on their own. Okay, it is not possible. All right. Hence, a SAN will always need storage plus servers. And when the amount of storage is really, really high, you will need a dedicated network just to connect these storage systems to these multiple servers. Okay. And it is the server which is controlling all the read and write operations to the storage system because it is owning the file system. Okay. It is owning the FAT. It knows which bus number, which partition to write the data in and where to read from. So all the control, okay, is there with these hosts or servers where the workload is running, where your database is running, where your web portal is running, okay, there. Whereas in a NAS, okay, who is owning the file system? The storage itself is owning the file system. Okay. So the storage itself knows, okay, where which data is written, what is the name of the file, everything. Okay. Whatever we just now saw, the file allocation table, the journaling, okay, everything. So is there any dependency on the server or the host? No. Can a end user directly connect to a storage and read and write data from it? Yes. And this is the primary difference between a SAN and a NAS. Okay. Who owns the file system? Okay. Now, what kind of file system we will see later. Okay. We will see later. But I hope now this difference is clear to all of you. What is the difference between a SAN and a NAS? Once again, in a SAN storage, the storage does not own the file system. Okay, it is the server or the host which owns the file system. Whereas in a NAS, it is the storage which is owning the file system. Okay, not the server or the host. Okay, so does this make sense now? That lady who wanted to store lot of data like patient data, large number of files, we will talk to them about how to use a NAS, or we will suggest a NAS kind of a storage to this lady. Okay. Whereas when we are talking about just one server, okay, small retail store, okay, his hard disk capacity is not enough. Okay. He doesn't have any more stores or any more computers, just one. DAS is more than enough for this gentleman. Any questions on what we have learned today? Sorry. Any questions? All right. So before we say bye today, I'll quickly. Oh, I'm sorry. I'm sorry. I'll quickly show the additional reading material also that we were talking about, right? So here it talks about a SAN architecture. So when you provision a SAN storage to these servers, this server for these servers, it's as if a hard disk is connected to it. Okay. This server operating system cannot make out the difference between a local hard disk which is directly attached to this or coming from a SAN. Okay. Then what is this block virtualization? Okay. What is a LUN? We'll talk about these a little later. Okay. Starting from tomorrow. What is iSCSI? Okay. We'll talk about this later. But just have a read, okay, of these things, and we will get into the details of this. Okay, here as you can see, this path, okay, directly accessible. So left hand side, SMB is used in Windows, NFS is used in Linux or Unix based operating systems. Okay, and that's how directly a Linux based machine like a Mac can access the storage from NAS, and a Windows laptop like you all can directly access files from a NAS kind of a storage device using these protocols called NFS or SMB respectively. Okay, and this is how a file system inside a NAS looks like. Okay, so now when you read this, you will have better clarity. Of course, not 100% clarity, but you will have a little better clarity now that you understand what a file system is. You will have a better clarity on this. Any questions? So what we have learned today is a layer deeper. We understood what a track is, what a sector is, what a cylinder is, okay, and how the actuator arm moves and identifies on which track sector to write certain data. Okay. Similarly, the same thing happens at a larger scale in a storage system. And who gives the instructions to this actuator arm on the hard disk as to which track, which sector to read from? It's the file system. Okay. Who owns the file system? The operating system owns the file system. Okay. If it is Windows file system, you will see NTFS. What does NTFS stands for? Network Technology File System. Okay. And each file system has got its limits. If it is Unix, you will see a different kind of a file system. It's called EXT. Okay. There are others also. We will talk about it later. And how do we identify if we have multiple hard disks in the same system? How does the file system or the operating system uniquely identify each and every hard disk? Because each and every hard disk is given an ID. How is it given an ID? Based on the cable using which the controller is getting connected to the hard disk. That cable is given a number, and that is called as a bus number. And the individual location in which the hard disk is put in that storage system, that's called as of course, the location ID. So a combination of a bus number and a location number can uniquely identify a particular hard disk in a storage system, even if you have hundreds of them. Okay. And each individual hard disk will have its details about serial number, manufacturing, who is the manufacturer, what kind of hard disk it is, whether it is SSD or HDD. And today in Bhanu's laptop, we saw a live example of how different types of hard disk from different manufacturers can be put in the same storage system, and yet it will work smoothly. Okay. Though we haven't seen how a single file system can spread across all of them. Okay. We will talk about it later. Okay. That's also possible. But right now, what we have seen is the SSD hard drive has got its own file system, its own partition, and the hard disk drive has got its own file system and its own partition. In a storage system, that's not what happens. All hard disks will be controlled under one file system. All SSDs will be controlled under one file system. And by using storage tiering concept, both of them can be merged together. Okay, and data can freely flow across SSDs and HDDs also. Okay, so slowly we are getting into complicated stuff. So it is very imperative that you all do the reading properly. Okay, understand each term, because as and when we get into more advanced, I will just say, okay, this is the file system. Okay, create a partition. Like this, I will be giving you exercises. At that time, I will not explain to you what a file system is, what a partition is, because we've already done this. Okay, so that is the reason why in the initial classes we are going to have more of reading, more of understanding, and as and when we move forward, we'll get into more practical stuff. Clear? Any questions? Any doubts? No? Okay, cool. Thanks a lot, girls and boys, for your time today. We will meet again tomorrow. Thank you. Have a nice day.